Hello students, today I am going to explain this one. Find the wavelength of emitted radiation of Bohr's theory of hydrogen atom. Okay, wavelength one. Energy I have told to you to explain, but I have already explained, but you have not sent this one. Energy. Please submit everyone. Energy. Okay. See now, this one I'm just going to explain. See, when electron jumps from outer orbit to inner orbit, then what will happen? It will give some energy in form of HF. We have seen. Okay, before also in second postulate we have seen this one. Okay. Nucleus is at the center. So when it jumps from outer orbit to inner orbit, then what will happen? Suppose N2 greater than N1, then what will happen? What is the relation? It will come. We will get the relation. We writing later on. Okay, now you see what is the energy. Energy for when electron jumps from outer orbit to inner orbit, energy will release. So what is the energy formula for N2 orbit? N2 maybe anything, maybe 2, maybe 3 also you can take, maybe 4, like this it will go on. N2, N3, N4, N1 maybe 1, like that. Okay, so En2 equal to minus mz square e to the power 4 divided by epsilon naught square N2 square h square. This one from where we have got, we have done energy deduction already. So from their energy formula we are getting this one. Okay, there is a E2 E1 like this. So suppose E2 is equal to this one. Okay, we are writing En2, N2 may be 2. Okay, En1 may be 1, like that. Okay, now what is En1 equal to? Same formula, minus mz square e to the power 4 divided by all constant 8 epsilon naught square, and instead of n1 we can write 1 2 like this also, n1 square h square. Okay, first orbit, second orbit, like this, n1, n2, n3. Okay, as the electron jumps from orbit n1, we are getting the formula we have said before. I have said E2 minus E1 equal to HF. Okay, from where we are getting this equation? See, we know E equal to HF from Planck's constant. E equal to HF. Okay, from Planck's constant. Now second postulate, what we can write? E2 minus E1 equal to HF, we know. So here instead of E2 and E1 we can write En2 minus En1 equal to HF. Now this one we have to put. We put this one. Put thus all values. Okay, En2 is equal to what? Minus mz square to the power 4 8 epsilon naught square N2 square h square, minus mz square to the power 4 divided by 8 epsilon naught square N1 square h square. Okay, then equal to what? HF, equal to HF. Then what is left? See, minus mz square e to the power 4 8 epsilon naught square plus minus will be what? Plus. Minus will be plus. So mz square to the power 4 divided by 8 epsilon naught square n1 square h square equal to hf. Minus plus. Then this one, mz square to the power 4, take common. This is common. Okay, this is common, this is common. So common one you take outside. Mz square to the power 4 divided by 8 epsilon naught square h square, take it common. Then what is left? 1 by n1 square left, 1 by n1 square plus, we are writing first, and minus, this is minus sign, energy release formula is already minus. Okay, we have seen that because it is energy is releasing. So minus we are writing in back, minus 1 by n2 square equal to hf. Okay, I hope this deduction is easy. I think you will understand. Okay, now next you see what to write. F equal to mz square e to the power 4 divided by 8 epsilon naught square is square into h. This h from where it will come? Because we are writing 1 by n square minus n2 square equal to hf. Okay, hf. So this hf we are writing, suppose just crosswise, h you bring it down, then what will left? F equal to h, 1h you bring it this side, so h square into h square into h is what? H cube, 1 by n1 square minus 1 by n2 square. This is equation number 1. Okay, Now the wavelength of the emitted radiation is given by formula, wavelength equal to velocity by frequency, velocity, where c is the velocity of light. So what is that? From c equal to f lambda we can write. So c equal to f lambda. Now what is the velocity of light is equal to 3 into 10 to the power 8 meter per second. Now what we can write? 1 by lambda, crosswise multiplication, 1 by lambda equal to f by c, 1 by lambda equal to f by c, crosswise multiplication. Now putting the value of f, this frequency, here this frequency 1 we are getting, okay, putting the value of f from equation 1, we have what? 1 by lambda equal to f by c. So instead of f, you write all the values. M z square to the power 4 divided by 8 epsilon naught square h cube into c. C is this one. This is the f value. Okay, this is the f value. This is the c into 1 by n1 square minus 1 by n2 square. 1 by lambda equal to m z square e to the power 4 8 epsilon naught square c h cube. Just writing in c here, h cube here. Okay, the same thing only. Okay, c in the middle we are writing 1 by n1 square minus 1 by n2 square, equation number 2. Now this equation 2 gives the wavelength of the emitted radiation, general one. Okay, given is the wavelength of the emitted radiation. Now for hydrogen atom, there are for hydrogen atom. So for hydrogen atom, what will be this atomic, that number of protons is equal to 1. So it equal to 1, number z equal to 1. Then therefore the expression 2 becomes this one. Put the values of z equal to 1. So equal to 1 means what? 1 into 1 means 1 square is equal to 1. So the 1 by lambda is equal to, if you put 1 square is equal to 1, then m e to the power 4 divided by 8 epsilon naught square c h cube 1 by n1 square minus 1 by n2 square. This is the equation number 3 for hydrogen atom when z equal to 1. Now 1 by lambda is equal to what? This wavelength 1 by lambda is equal to constant into 1 by n1 square minus 1 by n2 square. This is the constant. Constant means which one? All that values m e to the power 4 8 epsilon naught square c h cube, all are, these are constant values. This will not vary, only it will vary in number of orbits, that n2 and n1 it will vary, principal quantum number will vary, others will not vary. So now put the all values of here. Okay, mass of that electron, charge of the electron, 8 also, this is a constant, epsilon or permittivity of the free space, then velocity of light you have to put, then h to the Planck's constant is a whole cube. Now in calculator you do all this 10 to the minus, 10 to the minus, you just do the summation, all addition and all, you do division, multiplication, everything, then you will get what? 1.097 in 10 to the power 7 per meter. Okay, per m to the power minus per meter is equal to this value 1.097 10 to the power 7 to the power minus 1 is very important. This value is called what? What is the value? Rydberg constant. What is Rydberg constant? Separately, it may ask in optional question what is Rydberg constant, or optional question they may give the Rydberg constant is this. So this value you have to remember. Okay, m to the power minus 1. This is written by RH according to Rydberg, RH for hydrogen. H. Now equation 3 can be written as 1 by lambda is equal to, we are getting RH into 1 by n1 square minus 1 by n2 square. Okay, equation number 4. This expression is, okay, this expression derived from Bohr's theory, and it is written for hydrogen atom, and is called Rydberg formula. This is Rydberg constant, and this expression we are writing 1 by lambda instead of all constant, this constant, instead of constant, this value also you can write, instead of this value you can write RH 1 by n square minus 1 by n2 square. This one, this expression is called Rydberg formula. Okay, Rydberg formula. Now for hydrogen spectrum. Now what is this? Obviously wavelength or frequency radiation emitted by the accelerated atom are not continuous. They have discrete values depending upon n2 and n1. Okay. Now what is this for note? You can see by another formula we can see, this is up to this much we can write. This is for note to remember. 1 by lambda is equal to what? F if wave number is equal to number of waves in a unit length. So therefore F equal to RH into 1 by n1 square minus 1 by n2 square for hydrogen atom. Okay, RH equal to 1 by n1 square, and same only, 1 by lambda is equal to equal to, instead of 1 by lambda we can write f, frequency, when number of waves in a unit length, per length. Okay, so this is a note separately I am giving. So this is up to equation number 4. All equations we got in book. It's the continuation is giving, so equation 10, 11, 13 like that, 8, 9 is giving because of continuation, because continuation will not ask separately, maybe wavelength, maybe frequency, maybe energy, any question they can ask you. Okay, so this is the diagram, this is the note, this is a not rough calculation, this is already I have written everything, so you can study from here. This is a note I am sending, you no need to prepare this one. So okay, book also I am sending, and this is I have written for you, that this is a simple calculation also I have shown, so you can write from here this one. Okay, and energy one, none of you have submitted. Please try to submit the energy notes like this. Only you have to write from the book, and rough calculation I have shown already in this copy. I have sent the pictures, so you just add your rough calculation when I have done, and serially from the book you write and send to me. Write in your page number like this. Suppose anyone you are writing that maybe Susana, maybe Neighbor Coaster, and write the page number, one number 1 2 and name, and send the notes. Okay, energy one, I'll just see you can write or not. Okay, today up to this much. Next class I'll do another one. Okay, bye.